Newton's laws of motion and translational motion. Newton's first law, principle of inertia. When an object is subjected to several forces of zero resultant, it remains at rest if it was initially at rest, and in uniform rectilinear motion if it was initially in uniform rectilinear motion. So we have here this example. A person standing on the ground, he's subjected to normal reaction of support and weight. One is upward and the other is downward. Of course, we have a normal reaction of support on one foot and on the other foot. So the sum of these two normal reactions of support is equal to the weight in magnitude, but they are opposite in direction. So the sum is 0, and there are no other external forces acting on this man. There aren't any unbalanced forces acting on him. So that's why he is at rest and he remains at rest. And an example about if an object was moving and also the sum of external forces equal to 0, then if it was moving at a certain speed, then it will keep moving at the same speed. If you watch the video on YouTube, the second one, in which the man with long hair was explaining the principle of inertia and so on. At the end of the video, he showed an experiment of a ball that it was a metallic ball, and he was trying to move this metallic ball along a trail, and in order to keep a constant speed of it. Then this pathway was frictionless. So actually, when he removed that magnet, the ball now is under the effect of two forces, which are the normal reaction of support and the weight. So their sum is equal to 0, but still it kept moving at the same speed. So it was moving at a certain speed, and when the sum of forces is equal to 0, it also kept moving at the same speed. So I will attach this video again in the description of this video in order to watch it again. You can go to the end of the video and watch the experiment he did. Now, Newton's second law, which is the fundamental principle of dynamics, the sum of external forces on a given object is equal to the mass of this object multiplied by its acceleration vector. So, to get the wagon to accelerate, you have to apply a pull or a force. And if the mass of the wagon increases, this means that a greater force must be done to accelerate or to move this wagon with the same acceleration. That's why you can see by Newton's second law that the mass and the sum of forces are like directly proportional. More mass means more force is needed to let the object move at the same acceleration.